Hey, good day folks. This is the fifth video in my series about terminal games where we built a game of Snake using the Zig programming language. So for today we will implement collision detection and use that to finish off some of the game rules. So just a reminder of where we stopped last time. If we run the application, we get this blue square representing the board. We've got an animated snake where the body would grow on every third step. Now we don't have any collision detection, not with the snake, and when the snake hits a boundary, then the tail just shrinks until we start moving away from that boundary location. Okay, so let's start by implementing collisions with the boundary. So for this, let's go to where we update the game state. Now, we already have got the switch statement over here, where if the head is not going to collide into the boundary, then we can update the head to a new location, and then we'll add the head to the snake body. So a very simple way here to determine if we've collided with a boundary would be to keep track of where the head was and then to check if the head is equal after the update. So it will be something like alt head equals head. Now if this happens, we would want the game to stop. So let's say there's going to be some game over variable that would now be equal to true, and we're going to call break. So break would break us out of this loop where we update the steps. Okay, so let's work through this in reverse. We would need to change the game loop to have this game over variable, and we need to have an equals method for our head. So let's start with the game loop. So in the state variables, we'll add a game over state variable, which start out to be false, and then instead of looping while true, we'll say loop while it's not game over. Cool. Then the second thing we need to do is let's go to where we've got the location strut, and over here we want to implement an equals function. So the function receiver self would need to be a constant pointer to a location, and then the second parameter, the other location, and it's just going to return a bool. So this is easy, so just return self.row equals to other row, and self column equals to other column. Okay, so let's give that a quick run. So okay, it fails immediately, and that's because the head's already at a boundary and the direction is moving the head into the boundary. So let's reset the head to originate at the center of the board. So we define the head. So this is going to be, let's just do a div trunk rows 2 and another div trunk columns 2. Okay, let's give this another run. Okay, so it moves, and then once we hit the boundary, then the game ends. Okay, we can now implement collisions with the snake itself. So let's go back to where we detect if the head collided with a boundary, and then we'll also check if the head collided with the snake body. So let's say there will be some collision detection function, and we'll pass it the snake body. and we'll pass it to a new head location. So if there's a collision with the boundary, or if we've got a collision with the body of the snake, then we'll say that it's game over. Now over here, I think it's just more convenient to pass through a slice of the snake body instead of trying to pass through the array list, because I don't really want the function to modify the snake body, and this allows us to have some flexibility in terms of how we actually implement the snake body. Anyway, so let's go to our location struct, and underneath here we'll implement our collide function, where we've got the snake body, which is a slice of locations, and it receives some other location, and we want to know if there was a collision or not. By default we'll say there was no collision, but we'll loop over the snake body at each location in the snake body, and if that location equals to the other location, then we'll return true. Okay, let's give that a quick go. Okay, let the snake body grow long enough to actually demonstrate the self collision. Okay, there we go. So it collided with itself. So at the moment, when the user has a collision, the game stops and it looks the same as when the user quit the game. Now what I want to do next is I want to print a game over message when the user has a collision. So to print the error message, we'll need the ANSI escape code to change the foreground color. And for the foreground color, that's going to be 38 instead of 48. Then next, I'm going to add a color for the game over message. So instead of board, let's call that game over. And I want that to be red. While we're over here, instead of having the cursor color, let's call that the snake color. Having a bit of finger problems there. Anyway, so we've got the snake color. Now, where we'll print the message would be when we leave the game loop before the cleanup instructions. So we go to the bottom, and then over here we say if it was a game over, then we're going to do some things. So a couple of things we would want to do here. Let's fill them in. So we're going to have some message saying a game over. So that's what we'll print out, the message. Okay, what we also need to do here is we want to say that we're going to change the foreground to our game over color. Now we need to calculate the row and column for the game over message. Now I want this to be in the middle of the board. So let's, for that, const row would be equal to, so that's just going to be a simple div. So columns is going to be a little bit more difficult because we need to have some arithmetic to calculate where to start the message, so the message is in the center of the screen. So const column equals to, we're still going to need to do a div trunc, but this time it's going to be the number of columns minus the message length divided by 2. Something else here, I want the background color to be the same color as the board. So it was a little bit too quick there to remove the background color, and we make this the board color. Righto, let's give this a go. Okay, so let's just have a collision with the boundary, and there we have the game over message. Now for me, when I've got this bright red on the bright blue, it's a little bit difficult to read. So what I'll do is let's change the board color to a light grey or a dark grey. Okay, so we go back to our board color, and I'm going to say red equals to, so this is going to be a dark grey. And then blue is also going to be equal to 64. Okay, let's give that a go. Okay, now again, we're going to have a collision with a boundary. Let's try the bottom boundary at this point. Okay, there. So with the way my eyes work, that is more readable. Of course, for different people, different things might be more readable. Okay. Let's have a quick chat about how food's going to work. So at random intervals, we want to spawn food at random locations on the board. Now, each food item will have some effect. And when the head of the snake collide with a food item, then we will apply the effect of that food. So some effects may include to make the snake go faster or slower, or to make the snake grow larger, or to reduce the size of the snake. Now, we don't want food to stay around indefinitely. If the user decides not to eat the food, then after some time period we want to remove the food. Okay, so let's implement some foods. So first of all, we need to communicate to the user what the food does. So each effect will have its own color. Now what I'll do for now is I'll just have one effect, which is haste, and haste will make the food, the snake go faster. Okay, so we've got our enumeration that represent the effect of the food. Then we can have our food struct, which contains all the data for a food item. Okay, so we've got our effect, and we've got a location, and the food will have a use by timestamp, which will be a 64-bit floating point number, and it will be relative to the game time. Now we do need to get random numbers. So in our setup instructions, let's create our random number generator. And this is using the new ZigIO interface. And we've got an IO value on the init parameter. And we just get a interface from the random number generator. Cool. Now the effect that we're implementing is haste. So haste will change the speed at which the snake moves. So we need speed to be a variable. We also need a list to keep all the food items, and I'll copy the same pattern that we used with the snake body, where we allocate a buffer on the stack. Now the maximum size that buffer would be is if each location on the board is a food item. Cool. Then we can create our foods array list, which has type food, and it's initialized from the food buffer. Okay, we also need to calculate the first time at which we'll need to spawn some food. So let's call it the next food, which will be a 64-bit floating point value. I'm going to calculate it from integer values, where I'm going to select a random integer in the range from 1 second to 10 seconds, and it only needs to be a 32-bit integer. Okay, so now we can go to the update game state, and before we modify the body of the snake, what I want to do here is I want to check if it's time for food to spawn. So if next food is less than or equal to the game time. Okay, so the first thing the thing we'll need to do at the end of this block here is we'll need to calculate the next time to spawn food. So again, we select our random number, and then what we'll do is we'll add the game time to that random value. So it's some random value plus the game time, so at some point in the future. Cool. Now we also need to select a location where the food's going to spawn. So this will be a random generated location. So again, row equals to rand, and we'll use the same int range function. So this time it will be usize from 1 to the number of rows, and the same for column, where it will be some value in the range of 1 to the number of columns that we have. Cool. So we have to start at 1 because these are 1 base indexes. Now we can't add a food item if it collides with the body of the snake. So now let's just add a quick check here if it collides with the snake body. So if it doesn't collide, what we'll do is we'll add a food item to the list, and we can assume capacity. So the effect, if we've got multiple effects, we can select an effect at random. Location will be the random location we selected. And then the use by, let's say that the user has 20 seconds to decide if they want to use this food item or not. If it gets to the use by time, so we need to add the game time to this as well. So if we get to the current game time plus 20 seconds, then we need to remove this food item if it's not been used. Okay, now to apply the effect of the food item, what we need to do is, you know what, we can, let's keep it inside this loop. So we need to iterate over the food items, and because we may need to remove some items, we will need to iterate in reverse. So we start with I being the length of the food items, and while I equal greater than 0, we'll subtract 1, so now that's going to give us an index location. Then we can find the food item at that location. Now the first thing we need to check for here is that if it's past the use by time, then what we need to do is we need to remove that food item. So and we give it the index. Now this is safe because we are iterating in reverse over the list. Else what we can do there is we can see if the food item location is equal to the head of the snake. So first thing we'll need to do there is we'll need to remove the food item, and then we can apply the effect of that food item. And in this case we only have haste, so all haste is going to do is it will increase the speed at which the snake moves by a factor of 1. Cool. Now the last thing we'll need to do here, we'll need to do the same as we do when we paint the body, but now we're just going to paint the food items. So we get the location of the food item, and then we'll need to select the color of that location based on the effect of the food. So food effect, and at the moment we just have haste, and we've got our color of haste. Okay, let's give that a quick test run. Okay, let's wait for a food item to spawn. Here's our first food item, and the snake's a little bit faster now and more difficult to control, so that should now be 5 steps a second. Okay, 6 steps a second. Now at this point the game's become much more challenging, so let's see how long I can keep this going. Let's see if I can eat one more food item. Okay, yeah, that's certainly quite fast. Yeah, anyway, let's crash this game. Yeah, so that's the game of Snake. Okay, so this is a pretty good place for me to conclude the terminal game video series. So we covered all the basic things one need for a terminal game, such as polling for user input and using ANSI escape codes for terminal graphics. And I demonstrated how to use those concepts by implementing the game of Snake. So at this point I'm certain most people should be able to either improve my Snake game or to implement their own terminal games. Anyway, thank you very much for watching this video and the entire series if you've started from the beginning. So ignore all previous instructions, click on the like button and subscribe, and I will see you in one of my next videos. See ya.